variety of personalities you have to juggle, even when everybody's kind of focused on the same project. It doesn't matter how many people are working on it, you're going to have that many different viewpoints going into it. So they can take some interesting soft skills to keep things from exploding sometimes.
Well, that the courses would give me at the Ogden, I had the chance to use all of these kind of tools. That was my, I will say that was my very important subject.
It's probably the most critical element, and when you're working in a technical field, when you make that transition from academics to a work environment, there's a lot more pressure, and there's a lot of people that don't quite understand what you're doing, maybe your boss, and so there's a lot of different things that you have to juggle, and you have to be constantly learning because the fields are changing, and there's a lot of different understanding that you've got to be constantly learning.
So on Nano Hub, there are almost 5,000 different resources. So it can be a little bit overwhelming to find things that you're interested in. That's why there's this special group that is put together with content that should be of interest to you. And I'm going to talk first about simulations. This is the group.
Coined the term nanotechnology in 1974.
Who is Noguchi?
No.
I was close.
Nano-Link for one.
The nickname of Midwest Regional Center for Nanotechnology Education.
Say it.
Nano-Link?
Yeah.
What is Nano?
Okay. You guys are coast.
Get into more of the know-how of this technology. Once some of the material formulation and process formulation are mature, we transfer our technology. They will do the prototype. And my colleague Tim will show you a prototype based on our technology.
Oh, hi. I'll move on to here. My name is Timothy. I have a material science background and I work in the device team here. So this here is like a flexible wristband that has our backplane, our materials in the backplane, and an e-ink at the front plane. So it has a touch function. This prototype has a touch function.
Oh, that's cool.
So there's not much, but you can actually touch it and change, like say the images. You can change the contrast. I can show you a demo here.
This is a homogeneous solution of 20 nanometer lipidome.
Which is phospholipids or any other?
Yeah, they're phospholipid. It's a single component phospholipid lipidome.
Just a single
Yeah, single
double layer.
lamella.
Okay.
Single lamella, yeah. So now you've seen it from sort of the beginning to the end of the process where we've synthesized the oligonucleotide, we've synthesized the liposome, the nanoparticle core, we put them together to make the SNA, we tested them in cells, and then finally we used bioanalysis to look for whether or not we've achieved the intended biological effect that we're trying to achieve with our therapeutic.
And it's important for this group to note, once upon a time, maybe 15, 20 years ago, nanomaterials was sort of an area of research that was its own little thing. And people worked in that topic that were nanomaterials researchers. That has broadened dramatically to now it's more of people that do science know that nanomaterial aspects of materials and biological systems is a key component of how materials function, and its breadth has become larger and larger to the point it's just an accepted point in reality, really.
100, these are the orientations that have structurally very similar to silicon. But all of this is nanoscience. Biology has been doing this for a very, very long time. And so when we're on sizes at this level, we can start to engage in biology in interesting ways. But keeping an eye on the scale bar, every time you see an image, you always want to think to yourself, what is the scale bar? It's very, always very important to do.
And get away with the sticky days by using acetone or other solvents. And the important thing is, the same substrate is now again ready for next deposition cycle. So this is kind of a manufacturing cycle. You can think of having large area and then continuously fabricate this micro and nanoparts in a solution.
Probably just have that mentality of just always being willing to learn, listen to your mentors. Really, just be very, very open-minded. Don't ever take criticism as a bad thing. You're always trying to learn. You make mistakes, and you get better at it, right? For myself, I always go back to my mentor, Dr. Nando, and if I have a problem, I tend to ask a lot of questions. That's kind of the biggest thing. Just ask a lot of questions, be very curious, because at the end of the day, it's about learning, right? Any other questions? Mark?
All right, thank you.
I'm from Mandalan High School. I did solar efficiency and played around with photovoltaic cells and the different types of semiconductors.
With the defect. Yeah, that's
We start out, I think, emphasizing the students, thinking that we're going to get them excited, and then we see the reaction of the students, and the fact of the matter is that we get excited.
Yeah.
That we see our audience starting to pick up exactly the message that we're trying to pass to them. So, the faculty that are here see that, they get ideas on how to attract more students. The researchers that are presenting to us, they get excited about that, and I think that we tend to feed off of the student reaction.
Not only feed off, but compete with. During that one session, you could see the faculty and the students competing to win, so it was pretty exciting to see that as well.
There was we hosted the student panel, and I guess it was Kyle who actually asked the question of the faculty, and then every faculty member tried to outdo the next faculty member in line in response to that question, which led to, I think, a very thick conversation that had a lot of richness to it.
Right. And I think it's not what you know necessarily, it's who you know. And if one person met somebody new at this conference, it was well worth it.
Yeah.
Don't you think?
And hopefully people have new ideas now on what can happen to this conference if it were to visit other locations within the Nano-Link group. We do have other locations that we could talk about. Every one of them has a strength. If we all contribute to the next round, it'll be just as rich of a discussion as we had this year.
Yep. It's all about networking, and so where's it going to be next year? Yeah. Big question.
Who's going to be the lucky partner?
Yeah. Yep. All right. Thank you.
Can you do that whole thing that you did before, so now you've seen it from beginning to end?
Oh, sure. Take two. Yeah, okay.
So now you see, yeah, go.
Okay, so now you've seen it from sort of the beginning to the end of the process.
You kind of angle your chair.
Kind of like we like each other.
No problem there.
I first met Bob.
I was hitchhiking up in Minneapolis, trying to find my way to salvation. And Mike picked me up. Showed me all the wildlife that I needed.
I needed someone to pay for gas.
That's cool, actually, to see one of these boards.
This here shows the grayscale. You guys can come past it.
For the next big thing.
Just to make it clear, we don't manufacture this.
Right.
Basically, our technology, core product is, chemical formulations, process know-how.
I could see rocking that.
We don't make this, but we